Testing, testing. Hello. Hi guys. Oh, TMKK, Mini Chicken, Pyro Mike, and Dartha. Hello. You guys all beat Bellum today. Mini Chicken, it's been a while. How you been? Where is Bellum? That's my question. Bellum's always here. Bellum's not even in the in the users in chat menu, for once. Genuinely surprising. Alright, this is a unscheduled. What do you mean unscheduled stream? I said I'd be gone for 2 days and I'd be back. I had food. Oh, that looks really nice, Kandarsa. Are those dumplings? You sound sick. I have like a little bit of inflammation right now. It's not too bad. I have been like sleeping like 1 to 2 hours per night because I've just been so busy with everything. So it's catching on to me. I have 1 more week of this class I'm teaching, and then I get to like do finals week, and then I get to do school again. So I finally have access to the DALI AI. Messed around with it. I've heard about that. Is it pronounced DALI or like Dal? I don't know. Looks, it's like Wally but with like a D. I saw a post on Reddit like really recently that was like searching up last selfie like in the world, and it was like a really scary image. It's a weird name, yeah. And it's pierogi. Oh, is that like the potato pasta? I don't know what pierogi actually are. I just know it's like a carb. Alright, today, I have to build an Optocoupler isolation circuit for the PIC. I think that's what it is. Mashed potato dumpling. Oh, that actually sounds good. I would like to have some sometime. Okay, let me take a look at what I have to do exactly. I know it's something to do with like an Optocoupler circuit. Something to do with PWM. That's about all I got from like the short thing I watched. Do you need multivariable calculus for deep learning? I don't think so. It's just a bunch of like logic. I'm actually not sure what I'm making today. I just know it's my last lab, so that's what it is. I don't think I need any of this stuff on the top here. I know it's some kind of like motor control circuit using an optocoupler. I just need to find out exactly what it is so I can build it. I have had people message me like asking me questions about this lab, and I've been like I've been so busy I haven't had time to check on it yet. But if it's an optocoupler motor control, then it needs some kind of step-up current device, which means that it probably needs a transistor or something. And if it needs a transistor, I'm going to use my favorite transistor of all time, the 3806 MOSFET. This is my absolute favorite of all time, and I have 2 left. This thing. Isn't a MOSFET a transistor? It's a field effect transistor, not a BJT. I mean, it's in the name, Dartha. It's still a transistor. Did they say BJT? It's not a BJT, not bipolar junction. Cheating. What do you mean cheating? Learn to use PNP. Nah. I like MOSFETs better. Let's do NP and rep. Fine. I'm gonna use the 2N222 then. I know how to use it, I just don't like using it. Let me go get my stash of 2N222s. I don't like using it. It just feels so wrong. Where is my collection of stuff? Where are these things? I found it. I have so many of these I'll never use because. Alright, I got a 2N222. Let's take the scenic route with a power supply trim pot ohm meter. I don't actually know what I'm supposed to build so far. Hold on, chill. Do you have any recommendations for learning joints of robots like the shoulder and knee? How much are you driving? The motor is about 0.15 amps. Apparently. I don't actually know. Let me check. At 5 volts, how much does it draw? I actually need to solder some wires to this, so I'm going to do that really quick first. And then let you know. Yeah, 150 milliamp. Learning joints of robots like the shoulder and knee. So just like motors in general. I don't know. I haven't really looked into that field yet. I know about like basic robotics, but like not in that area. Okay, let's see what I have to do. You use a PWM mode to control the speed of a DC motor. In my case, a 5-volt computer fan. Use analog 0 as your analog input for the ADC. Use CCP2 to generate the PWM signal. Isolate the DC motor from the microcontroller using either a transistor or using an optocoupler. Okay. Fine, I'll use an optocoupler. What should the resistor be between the optocoupler and the PIC? Do it like an LED. Yeah. Okay, I'm gonna draw it out first before I do anything else. Back. All right. So optocoupler circuit. So you have this thing, right? This one's a diode. And it shines the light onto the transistor. Just like connected to these 2 pins here. Okay, you have a resistor. What do you use? Probably like a 330 ohm one. And this one goes into the PIC. I guess the CCP2. Which pin is that? The lab wants me to use an optocoupler, and I want to use one for that. It's going to be an optocoupler into a transistor. Why is it not showing? Oh, there you go. Yeah. The optocoupler, the motor isn't able to draw enough current from the optocoupler. I looked on the data sheet. It only goes to like 50 amps at 5 volts. I'm also only allowed to use 5 volts. In this case, I'm not drawing another power source. PIC is powered by 5 volts. Theoretically, you should have like a motor up here, right? And then a flyback diode. And then like a 5-volt source. And this goes to ground. Theoretically, right? But like it's not able to draw enough current in order to actually power the motor, apparently. So you connect this instead to the base of a 2N2222. Which is to drop the schematic here, because I keep forgetting how to like connect this up. Let's see. Transistor circuit with optocoupler isolation. Okay, so then this goes to 5 volts. And then you put this to like a 330 ohm resistor. Depends on the current going through here, actually. Is it 330 or is it 10K? I don't remember. Maybe it's a 10K. Maybe. 3 or 5 volts. Yeah, I think that's the correct one. So that goes into the BJT. And then you'll have the motor here at 5 volts. And then a flyback diode to protect itself from things. Right, and this goes to ground. Does it look about right to you? You shine a light into LED and makes power. That's what light is switching on the other transistor. Yeah. So this is transistor A. This is transistor B. That light is gonna, yeah, put any unnecessary light to it. Does it look kind of right, Conarza? Is that how this thing works? You have diode 1, you have diode 2. Theoretically, let me look at the current chart of the 2 and 2, 2, 2, 2. Data sheet. So I have a diode and glass tube to hide it from light. 10K is too high. Okay, yeah, that's what I thought. I'm gonna use 330 instead. This is gonna be PWM signal, by the way, on the left here. Yeah. The right resistance should be 330 ohms in order to get the 10K, I believe. Because it's a 5 volts at 330 amps, then the base current is going to be 5 volts divided by 330. That's high current current, right? VOR. Here's my calculator. Ugh. .015 amps. Okay. And then the chart is saying that the collector current MA, and then the will be no, not that. Yes, I'm left-handed. I like this one. This, which one? Oh yeah, let me see this. Why are there two BJTs? One's a pull-up. There's two flyback diodes on that one. 5 milliamps into the 470. So it'd be like two BJTs. But you don't need to add the secondary linear. You can just add the other resistor in. So it's a self-biasing circuit, right? Okay. So it'll just be a resistor down here. It's been a while since I did these calculations. Like this. Oop. But like this one would have to go to 5 volts or 12 volts or whatever the heck it is, right? Two BGT is a Darlington, so just don't need that. I'm just saying the resistor placement. Okay. So, you want to pull up the gate to turn it off. And then second the gate, the switch is on. Okay. Got it. So... 5 volts here. Then the resistor values for the top one. Can I use 10K for this? And 330 ohms for the bottom? Or 470 ohms? Yeah, okay, cool. This is a motor. I do need to add a flyback diode here though. Because like I've had too many nightmares of not using flyback diodes for motors. Don't need the other 5 volt going to the opto. This one? How's the optocoupler going to get power? Oh no! Wait. I drew this wrong. I get it. Hold on. Pardon my stupidity. Right, so that the top of the optocoupler goes into this thing. And this goes to ground. That's why it had a fun little thing. The BGT will drive without the flyback. Okay. This is 470 ohm. Should be self-biasing in this manner. I'm still looking at the Yeah, is it not supposed to be PNP? Oh, it's a PNP circuit. I don't have a PNP transistor. That I don't have. No, it's NPN. Okay. Just making sure. Let me check currents. Current check. Vibe check for currents. Nice, because if the BJT on the left turns on, that will pull it to ground. Right. And then this current that's coming through is 5 volts over 10k ohms, which is like 500 microamps. The motor's on 5 volts. And this is why I suggested using a 30N06 MOSFET instead. This is why like NMOS is better, because these are so complicated. Unnecessarily complicated. MOSFETs, you just apply a voltage and boom, you're done. Which resistor? Here or here? This one's to pull it up to 5 volts, so that if this turns on, this connects, right? And then this will go to ground, right? And that will turn this... Hold on. Wait, that doesn't make sense. Wait, this NPN will turn on if... It'll go into saturation mode. There's a current going into it. Shouldn't it be the opposite? It's negatively switched. Yeah! Oh, is it negative? Hold on, I'm getting confused by chat. So when the GPIO is low, the motor runs. Oh, so it's like it's inverting circuit. Well, I was thinking if the GPIO was high, the motor runs. I was designing it for that. Really. I was designing for the opposite thing. Wait, what op-amp? What op-amp are we talking about now? I'm getting my 30N06 ready. Right, here's the alternative circuit, right? Here is what happens in a perfect world. I'm gonna duplicate this thing. In Canarsis' world, we use a 2N2222, right? Yeah, theoretically, right? You turn the GPIO pin on the PIC on, and it turns on the motor. You turn it off, you turn it off. Like that's the I think that's the expected behavior. You don't have to like go too complicated with this circuit. So if you use a NMOS, How do you draw like the NMOS circuit diagram thing again? GPIO high and the power stops. Is that usually how these things are designed? Okay. Watch this circuit like not even be what I'm supposed to do. I'm just gonna get like points docked up because I'm not supposed to like build a circuit in the first place. Actually, that's fine. I can have that. It's an N-channel MOSFET, so the arrow goes downwards. I don't like that. Let me show you guys what I had in mind to build the circuit in the first place. Because this is why I don't like 2 and 2, 2, 2, 2s. I had one blow up on me like earlier this week. It's like transistors in general. See, 10K pull down into an NMOS. You can change the sync source on the GPIO and activate the mode by going through N-channel S arrow inside. No, it's not. For the circuit diagram? No, P channel. No, hold on. P channel is like this, right? N channel is this. I gotta Google this. Hold on. Have I forgotten how to draw a MOSFET? Alright, you know what? I'm building it using 309060. This should theoretically work. If this connects, then this will also have 5 volts. Unless you short it to grounds, that is. This will be the alternative. I've drawn a JFET. Alright, you know what? I don't have time to do this. I have to complete a test later. I'm just going to build a circuit, and then we're going to deal with the consequences if it doesn't work later. Okay, so what do I need to control this with? Google a similar look in the book. Alright, let's see. Alright, where's my wire? I gotta get this done. Alright, so I need to go ahead and build the circuit on, I believe, the CCP pins. I know this cutting thing is going to take me a while, so that's why I need to decide on circuit building now before it's too late. Pick a 10F data sheet. Like 2N2222, I can build a circuit using that, but it'll take me less time to figure out what the NMOS, because I've used it before, and that's what I'm going to go with. And it's just my opinion on it, because I don't want to I don't want to spend more time dealing with this than I have to. I can already tell that tonight's going to be another like 1 hour of sleep night, because I also have to finish another assignment, and then I have to get prepared for the class next week. So, in that regard, that is why I am choosing to AN9 CCP2. That's why I'm choosing to do this right now. AN11. They have to turn off AN9, which means I have to use AN8 35. Did you see the question? Yeah, I did. About the hold on. About the learning joints of the robot one. Sorry, I'm a little slow today. I didn't get much sleep last night. Yeah, I don't really have much experience with that. Sorry about that, Mini Chicken. So I may not be the best person to ask about that. But Canarsa TMKDK, I'll when I have more time in the future, I'll go back and make circuits with the 2N2222 and that kind of configuration. I just don't have the time to do so now. Oh, which food ingredients do you hate the most on? I don't like cilantro. That's an easy one. So CPCB2 will be the output, AN1 will be the input. Okay, I probably shouldn't have pulled that out then. So it's going to be a potentiometer input again for the analog input. Okay, so this thing has to go to AN8, which is pin 35, which is 2 pins off from VDD. Bit long. Thank goodness I pre-cut these wires, so it'll take me forever to like not do so otherwise. Get the Optocoupler. Okay, so the dot is on the top left corner. I have to use the right side to generate the circuit. So 1 and 2 are on the wrong side. One is going to be where the dot is, 2 is going to be the ground. Okay. So I'm going to need a hold on. I did not see the chat. I've been scrolling for so long. This pin 16 and 36 are the same thing. They both have CCP2. Yes, it says it's the alternate pin for CCP2 multiplexing. They're both the same thing. Now, what if it agrees to him? It's going to be the H to the P. Yeah. So let's go ahead and do the PMP later, and you can teach me all about it. I just like don't have time for it right now with all the signs I have built up. So, but gonna finish this like lab with something I know how to do. The dot is always the pin 1 unless the firm wants to F with you. You know what? Considering all the sketchy ICs I just bought from China, probably. That's an argument we can have for another day. Let me get out my my trusty 30 N6L8, which has never ever failed me before. Alright, and I need a 10 k ohm resistor, which I have over here somewhere. Okay, so pin 1's going to need a 330 ohm resistor from one of the lines, and I think in this case it'll be AN8, which is going to be my analog pin, and then RB3 is going to be CCP2. So RB3, it's too long. Yeah, always look at the data sheet before guessing. That is a very good idea. Why are these so long? What did I do with them? None of these are cut to size. So yesterday I was working on like a LiPo battery circuit. I'll show you guys. This was a little side thing I was doing. It was measuring the cells of the LiPo battery. So you plug it in here. Oh, I should have probably asked you about this actually first, because like I could not get this stupid multiplexer to work yesterday. But I'm gonna talk about this later. I was building a Forest LiPo battery voltmeter using the Arduino Mega, and I was going to measure like 8 different batteries. And I was trying to use this multiplexer to give me more ADC pins, and it just didn't work. So, I'll get into that later. Which, like, I also have to do that project like tonight, but you know, that's an issue for sometime later. I created a small fireball in my room yesterday. Accidentally. Alright, I need a 10 k ohm resistor. Where are my 10 k ohm resistors? Where are they at? And 470, 10k, 1k, give me. Well, to show you what mux that was, I was googling the datasheet earlier. I'll send you the datasheet for it, and then you can help me like see what was wrong. It was like reading lower than usual, which was like really weird. I couldn't figure out why. Was that with friends for once? Hey, nice. Oh, so this first one is a 330 ohm. I don't know what 330, so I'll just do a 470 to cool. Yeah, so one project at a time. I'm already overwhelmed. I don't need to be more overwhelmed. All right. Was the other board that you printed the other night? Yeah, I printed 8Ks for this board. Like, I print project boards so that I can just, like, handle these around, like, really easily. This one has a bunch of breadboards, an Arduino Mega, a small one for an OLED screen, a control panel for buttons, and then a Raspberry Pi. I didn't feel like cutting these wires to size because I didn't have the time to, so this is the reason for that. I have, like, a lot of different boards for projects. Oh, thank you. Looks nice. Thank you, thank you. So I got one of the optocoupler connections in. Oh, do you eat food with onions? Oh yeah, I completely forgot getting chicken, but yes. I do eat food with onions, but I don't like raw onions. Like, caramelized onions are pretty good. You did not see my food picture? Let me get you a picture of my food. That isn't 5 volts. What do you mean? What do you mean? What isn't 5 volts? So that'll go in. You fixed the address on my package? Yes, I did fix my address on the package. Niac finished packing those together. They should be out by this weekend, basically. So keep an eye out for that. So one is going to here. No, I screwed up. That's not one. Hold on. I'll just bamboozle this. Oh, no. I was like looking at it. I was like, huh. Well, this. I remember that Bellum said he had moved the last time I sent him a package, so I should probably ask him about this. And that's why I asked. Because I remembered. Bellum moved. And Bellum is no longer at Martin Luther King Jr. address. So 1, 2, and then 3 is going to be going to ground. No. 3 is going to be going into the MOSFET circuit, so 4 is going to need to go to 5 volts. Oh my god, you just doxed him? What do you mean I doxed him? Bellum doesn't live there anymore. You just dead addressed him. There's like 5,000 streets named in the country, yeah. I'm pretty sure you can find Martin Luther King Jr. like in California if you really wanted to. We really tried hard enough, you can find out where Bellum lives. Really tried hard. I mean, if you try really hard, you can find out where everyone lives. My grandma lives on one in a different city. There you go. I just might have doxed Bellum's grandma. What does the name Locofuck mean? Oh, I just remember that question. Well, Lock is my Chinese name, and Fafa means child, so I guess it's just me as a child. I don't. That sounds weird. Don't like think about that. My dad gave it to me when I was like in 4th grade, and that's what I've been using for this like entire time. That's the story of that, and that's all you need to know. So if I turn it this way, no, if I turn it, yeah, turn it this way. This is what we're looking at. No, 4 is going to this area. You need an FAQ command for that, maybe. But I do like explaining it all over and over again every single time, so maybe not. The story you told me was longer. It may have been. I should probably add one with a description. So this is a child stream. Yes, you guys are watching a child stream. This needs to be shorter. What the heck? It's okay, he asked his parents for permission. My dad thought you were a kid when he saw the stream once. I was like, this dude's like 20? Close enough. Define kid. Maybe Bell can make that command. Maybe. Bell, I think you watched my stream a little bit too much for that to happen. Like 10. What was I doing? I don't think like a lot of stuff I do matches the stuff that 10-year-olds can do, really. If I'm gonna be honest. You're playing the Line Racer game with the music. The what? I don't remember what that was about, if that was a thing. Alright, let me just stuff this in. Okay, now I completely forgot the circuit for this, so let me just go ahead and... Oh, sound voltex! Ah. Okay, that's probably reasonable, if that was actually the case. $10K resistor. 30 NO6LE. 30 NO6LE and MOS. Data sheet. Line Racer game. I like that one. There's some crazy 10-year-olds that can play like Osu and stuff. I've seen. They're nuts. They're simply nuts. Alright, so we need the source to go to ground. Source is gonna be the one on the right. I used to play OC, but when this was younger, this has been out for so long. Yeah, it's been out for like almost 10 years or like 12 years or something like that. Something crazy. Such an old game. I remember when Speed over Beethoven came out. I don't even know what that is. I know Beethoven Virus, like the one that was played a lot in like the DDRs and stuff like that. I remember like my cousin had a Dance Revolution like set up. Do you know what the most loved planet is? Is that a reference or is that an actual question? So that song was added 2014. I don't think I've been playing since 2014. Gates is going to be the one on the right. So then this is going to go in the middle. Like, I bought one of these pliers for myself and Niacy. I really like these. These are really expensive, but these are really good because they have, like, it's spring-loaded, and they're really, like, nice and pliable, I'd say. I don't know if that's a good word to describe one of these things. And this resistor doesn't fit because it's too fat. Pliable. It's Saturn because someone put a ring on it. I see. Jokes. Team KDK jokes. Okay, I need a terminal block connector and then a flyback diode. T-block 2, and then a diode. Those Harbor Freight ones are not very springy. They're like the Vice one I had was not springy at all. It was just like static. I think like these have been like the longest 2 weeks of my life so far, just because of my sleep schedule and all. And maybe such an irritable person. I can see. No sleep just makes me get annoyed over like the tiniest things in the world. Can't wait until like I'm done with all this, and I can like get back to being on a normal sleep schedule, like from like waking up at 10 a.m. I have to wake up at like 6 a.m. every day, and like while that's nice and all, it's just hard. Like I hear like people saying that you should wake up at 6 a.m. every day because like it's good for your health or something. I don't believe them. I've tried it, now I can say I've actually tried it, and the verdict is I absolutely despise it. Humans should not be. I know, right, Kanarsa? Yeah, unfortunately, the class I teach is on the East Coast, so it actually starts at like 10 a.m. for them. But for me, I have to get up at 6 a.m. to teach them. So it has not been a fun journey for me. Okay, that should be a good flyback. Then you just need a red wire to act as the power for it. The blue thing is for the motor. I'm going to attach a wire onto the motor and then screw it in. It's called a terminal block connector. Yeah, see, here's the problem. I don't have the right amount of sleep every day. Because I get off work at around 3 p.m. and I immediately begin working again for school. Because I have to catch up on my lecture material and all my midterms and exams and stuff like that. And then I do my projects, which also takes time. I do this stream sometimes when I don't have midterms, which takes time. And basically, I go to sleep at around the same time, actually, which is around 2 to 3 a.m. It's like more productivity and all. And I have to get up at 6 a.m. the next day. And also, I have to factor in the fact that I prepare for my classes like a day before, too. Like, I spend around 3 to 4 hours just preparing for the next day of class. Being a teacher is hard, I would say. Like, now I understand, like, all the other teachers that have to do this around the world. So, no, I do not have the right amount of sleep. I think this is in the right direction. I'm gonna regret this later. Teach me 2 plus 2. 2 plus 2 is Alright, Bella, which base are we in? Base 2, base 3, base 4? If it's base 2, then it's... Actually, what is base 2? No, if it's base 3... base 89. I think base 89 would actually just be 4, right? Because it doesn't overflow into 89. I don't know. My decision making has just generally been like really off these past weeks. He got you. I don't know this stuff. Well, can I just convert the binary hex? You can. Yeah, you can. So this is just going into the middle. All that sleepwalk or can't sleep there, can't sleep, test and analyze is often they can't just miss sleep. The brain is stressed. I was only a math minor. Oh, too bad. You need to be like a math major like Positron in order to get like full understanding of bases. And come back when you have your math major or a master's in mathematics. Anything over base 4 would be 4. Yeah. You know what? I need like force myself to sleep after this. I need like a good night's rest. In order for me to like not completely fail in this midterm I'm gonna take in a few days. Like, I'm okay with 6 hours. Like, the problem is I'm not even getting 6 hours these days. Alright, I'm going to go ahead and cut some wire now for the motor. I'm going to use the different kind of wire for this. I have my storage. Actually, no, I'm going to use solid cord. I'm not dealing with, like, strands of copper today. Not today. Not today. This is why I only took easy classes where I already knew the material. I mean, this is an easy class. I already know the material. Why am I spending, like, 8 hours constructing a circuit? Like, I wouldn't be doing this if I had to, like, study for this class as well. What am I doing? Let's cut a length of wire. You can wire a space shuttle at this rate. True. These 2 wires are going to be attached to the motor. I'm going to go solder this and I'll be back. I can bring you along with me. Alright, let's go do some soldering. Welcome to the soldering station, where I do soldering things. How's the view, guys? Alright, time to make some amateur pretzels over here. Field trip. I hope you're enjoying yourself. I am absolutely not. I am perpetually stressed until I can... Actually, until winter. Like, after this week ends, I have a final week of the course I'm teaching, and then I have finals immediately after. And then after finals, I immediately have school again. So you might say I'm in a perpetual amount of stress. Okay, that's as straight as I'm gonna get it. Alright. Why was this thing like $40? There's no need for this thing to be $40. I can't read chat when I'm over here, so I apologize in advance. I'm not setting up my phone. Nice small solder fumes. Ah, my ears! Whoever that was, thank you. I don't know who that was, but hi. I will check later. Please hold. Oh, thank you ×2. Whoever you are. I don't know if it's a follow, a donation, they all sound the same. It's not welding itself. Come on. Do a thing. Bend this wire like around. Soldered. get soldered together decently well enough. Okay, gonna do a motor test. About 5 volts here on my power source. It's not even clipped. Oh, hold on. I can't even test the device because the ends are not clipped. Alright, I'm reading chat now. Oh, thank you for the 200 bits, Bella. Positron is the math major, Condarsa. Whenever you get back, someone tell Condarsa that Positron is the math major. Ah, Condarsa is back. Yes, ask Positron if your math needs. Or whatever he's named these days. Positron's here! Hey, good timing! I called it. Alright, Positron, Condarsa has called you to answer some math questions. Drawing 1 amp max. Okay, let me see how much current I can limit it to. Five volts. About 0.8 amps. So the lowest amount of current it can run at is, let's see, if I turn this knob down. Okay, I think it should be fine. I got a bunch of these like motor tools, question mark. It was like my first motor kit, and it came with all these kind of like fun motor things that I can put onto this motor to make it funner. Let me find it. Somewhere here. A bunch of like motor holders. I found it. Yes. So I can have like a motor fan if I wanted to. I'll have a red fan. Why not? They can blow us away. I wonder if it's turning the right direction, even. Alright, fan test. Oh, it is. It's blowing in the forwards direction. It is drawing 1.55 amps though, which I don't think the transistor... Wait, no, my transistor actually can't support that. Oh, okay. I'm not sure if my power source can support that though. Alright, I'm gonna need to like 3D print like a holder for this to work. Alright, we're going back. That's not fun for today. I should probably also heat shrink this so that it doesn't come loose. I'll heat shrink it later. I don't feel like doing it right now. Alright, note to self, make the 3D print thing. And also heat shrink the ends of the motor together so you don't like short yourself. Alright. Let's see here. So the motor will go into the motor will go into these two pins. Let's clamp it down. Alright, so this is the circuit. I have a fan here which will turn on whenever something cool happens. It's connected to an NMOS, which is connected to an optocoupler. This NMOS I should probably cut some of the stuff off so it's like level with the ground. Alright, time to behead the MOSFET. Look away, guys, look away. A little more off the top. Alright, that's good. Optocoupler into an NMOS into terminal block connectors from a CCP pin, from a PWM pin. What could go wrong, right? Let me just like stick this in here. Give it like an extra pull. What can I stick this on to make it work? Sure. This is just temporary. So you can see my circuit works. Alright, I should probably clean it before I upload some code on here. So just as a safety thing. One amp at what volts? 5 volts. Oh, you were able to hear that? That sounds like a dental drill. Alright, I'm gonna go ahead and turn this off so I can clear the table. Because there's a lot of stuff here. I'm gonna save the pot, save the dip switch. I'm gonna throw away everything else though. And save the resistors. So, it's all dirty here. I'm gonna save some of the wires I cut for later on. My stash. Alright. White box system cleaned. Let the testing begin. Alright, let me get my power cable. So I'm gonna go ahead and disconnect the motor first, just to make sure it doesn't like just explode on me the minute I turn it on. Let me just put away some of my tools first, just to be safe. Just not overcrowd my workspace. So power cable. I don't know if the AMS 117 can draw 1 amps. I'm pretty sure it can't. Like, so my power source is already fried. Okay, install my voltmeter. Good. Where to put my screwdriver? Here it is. Okay, disconnecting my motor first, just so it doesn't like run when I run the code. And then putting in my pick kit. Let's probably get a little of this. All right, what code am I downloading into this thing? I just realized I'm running Unity. Oh, that's not good. In Automata Theory. Wait, is this LTL or RT? I just learned about this. Like today. I know for like Automata Theory, if you have like an LTL system, it uses kind of like some weird symbols that are not entirely based on math. Alright, MP Lab. I have like way too many tabs open. Oh, hey, Rufsu! How you doing? Good to see you here. I'm just building a new project. Pick 18F4321. This thing's not on. I don't know if it recognizes it. Redeem, drink some water. I don't know. Oh, okay, I'll drink some water. I have water here. Don't worry, I'm drinking it. What's Automata? What's the other matter with you? Why is it not recognizing my pick? The last USB you connected to this computer malfunctioned and Windows does not recognize it. Okay. Didn't like that. I can tell you right now, didn't like that. I don't think this USB cable works anymore. Alright, where's my other USB Type B cable? That one just didn't like existing anymore. I don't think. Yeah, I don't think it liked working. Let me find another cable. Where are my convenient USB Type B cables when I need them the most? It just so happens I have like a billion USB Type B cables here. This is a 3-foot one. Yeah, I have so many of these. For my macro board escapade. right? New USB cable. Work for me, please. Yes! It's alive! Alright, so that USB was just trash. Okay. Whoa. Alright, I have my new lab open. Let me just go ahead and make the new files. This is a motor control. And then a C header file called config.h. And then I'm going to put this in a liquid crystal. So, C header file, liquid crystal.h, and then liquid crystal.c. Okay, now that I have all my files, I'm going to copy paste some code in. Starting with the code for liquid crystal. Okay, and then liquid crystal.h. Okay, then config.h. Okay, and then finally in motor control, I'll copy that code as well. Now I have everything set up and ready to go. In motor control, my professor said to copy it from his code, so fine, I will. Model 10 CCP. PWM, display timer 1, no CCP. What does CCP stand for? PWM ADC change duty cycle. I think that's the one. Use the ADC to control the duty cycle. FPWM is fixed. I'm pretty sure this is it. Okay, now I just need to change my my pins here. Okay, 80con1. So I'm using 88, so I need to be careful about this. Just need to make sure this doesn't get hot. So I'm using AN8. So on the, because like CCP2 is on AN9, so I don't want to multiplex that accidentally. CCP is also often the burning voltage. Is it really? So add con1. Closed circuit potential. I'm not sure. It's for PWM. I just don't know what CCP stands for. Maybe it's in the lecture. I haven't watched it yet. It's not something that's easily Googleable. Okay, what am I looking for? I need AN8 to be an analog pin, but not AN9. So it's 0110. So 0110 AN8, but not AN9, so 0110. It's going to be 6. So 0x06, I believe. Oh, capture, compare, PWM. Ah, okay, that makes sense. That is a good. Thank you for searching that for me, or getting that for me, Condarson. There are so many short names in electronics that many is used again for other functions. I see. I thought it meant like clock or something like that. I just know it as PWM. 0110 is 6. So 1, 2, 4, 6. Okay. And then TRISP AB RA01. No. RB0. TRISP B bits. And then this is going to be on RB. It's going to be RB3 equals 1. And then on CCP2, it's going to go ahead and write it, I think. Okay, so I'm going to go ahead and transfer some of my code from one of my labs onto here, just so I can see it on the LCD screen for debugging. So this is going to be on lab 10, I believe. LCD counter. Okay, so LCD is going to have port A display, and then electricity like that. And then LCD counter, pin setup, and the LED initialization. I'm gonna have to include the liquid crystal stuff. Define the LED as port C bits RC1. I don't think I need the LCD, right? Or LED. What is it writing this to? C1. Motor as port B bits RB3. Alright, so find motor. He doesn't even use motor anywhere inside this inside the script. Okay. So he says it as a, I'm gonna use like a volatile thing. 9. Volatile int num. PWM duty cycle. Might be that. AD rush. No, AD rush is high. So the number, it's going to be AD res L, or and then AD resh Left shift 8. I think that's the operation to get the number. And then I just do a thing with the LCD. Display results on LCD. PWM. Okay, I think they'll get it. Let's try that out. Let's see what it do. Let's connect to programmer. Yes. 0. It is absolutely not changing. I am glad I am not connecting this thing together. All right, so now it's time to find out where I went wrong in my logic. 80 rush 8 left shift 80 res 0. Wait. This is just the interrupt for the potentiometer. So like I should be able to get at least this part right. At least the thing's showing. You need to pull power off the VCC in my opinion. For what? Why is it 0.5? What is that? For the motor? The motor's not connected. The motor's not connected. I'm just testing the ADC values. I don't know why that's like that. It should not be like that. That is not a 5. It's not supposed to print anything. I think it's getting its information from port C. There's C with an underline. It's getting stuff from somewhere. Channel 0. Oh, it's on the wrong channel. It's supposed to be on channel 8, I think. Yeah. Oh boy. Okay. We're getting something. That's a beautiful number. Okay, that's still not right, but we're getting closer now. 80 res L. Wait, is that not a thing? Oh, 80 res L. Right. That's not the right PWM. Or just random data, maybe. Yeah, that doesn't look like. Whoa, 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 that's... Are you seeing this? I think I'm controlling the wrong PWM. I think I'm controlling the PWM of this LED and not the, not the motor. What am I doing? I'm measuring it from this potentiometer, and then I'm putting it into this, into the motor here. What am I measuring? What am I doing? Set main. It's responding somewhat. That's not how it's supposed to work. Yeah, I know it's not how it's supposed to work. Why is it turning all the CCP pins here to like false? Okay, I'm gonna pull an executive move and I'm gonna switch those. Because I want it to be like, black on the left, red on the right. I just flip this thing, it'll magically work, trust me. There we go. Now it goes from 0 from the left all the way to 4.9 to the right. Okay, what is going on that I'm not seeing here? This is the exact same code. Why is one doing different things than the other? I'm commenting out the PWM stuff just in case that's the thing. Main says main project. Oh, it's not even connected. Haha. Okay, now we're back to this. Why is it doing this? Why is the PM... Why is it going from 0 to the int max and then like stopping there? What is like different from like this code and the one I just previously ran? RB2, not RB3. RB2 thinks this is output. I think that's what it is. Yeah, that's what it is. That was not it. That was so not it. It's not even showing a number now. Just RB2 is an input. AN8 is going in, but AN9 is going to be RB3. Just gonna put this here. Right, because the motor is going to be the output. It's gotten worse. Like what? So it's not 0x0f, it's 0x007. Except that. Okay, so I put tris b as 0x07 in hopes that it'll do the right thing. Okay, still nothing. It shows a number on here, which is like not right. And there's still no number. Okay. That's great. It's on the right pin, right? Nothing's hot. So, that's good. I burnt my finger yesterday on like a hot chip. And that wasn't fun. So how is it working for the other one, but not this one? Zero x02. Did they configure my ADCOM one wrong? 0x02. Let me see if that's the case. Oh, I see a number! I see a number again! I don't think it's the right number, but it's a number. So it gets up there and then it overflows. Why? I wonder what happens if I give it a long instead of an int. Why is it getting stuck? It's not even the right number. A rush H left shift 8 or 80 res L. Yeah, that's the right thing. Oh man, okay. Oh my goodness. Okay, I think it's... Hold on, let me check this. 81F and 81E. 81F. And then pin set 81F equals 0. Okay, that's right. All the ADC... All the ISR stuff is right. PMW frequency, PMW period. Oh! I found it. It's setting RC1 to 0. So it's doing weird stuff on RC1. So Tris RB is going to be 0... Wait, no, 1000. No. 0100. So that's 4. So 004 will get that. And then Tris B bits RB3 will be CCP2. It's gonna be that. That's that bit. And then it's gonna be 06 for that 80con 1. Okay, I found it. Is it doing anything? No. Absolutely not. That did not change anything. Did not like that. Okay. What else? What else could go wrong? It's reading the potentiometer input. It's setting up CCP in 2P and PW input mode for bit 3. Port B. CCP2 con bits.ccp2, and I don't change that. Prescaler. Set 80 input channel, turn 80 module on. All of these things are true. Why is this scaling it so high? What if I just force Tris... Force 80con 1 to be like 0602. Will I fix it? It's supposed to be from 0 to 1024. It is not from 0 to 1024. It's going from 0 to like an integer maximum and then looping back around. It's like the entire signed int range. Why is it doing this? Why is it... Okay, so 0x06 was right because I need that init pin to be digital for the CCP2. What other settings am I missing? ADCS equals 0, ADCQT equals 1, 80 con bits 80 FM equals... Ah! I found it. Right justified. Okay, and then channel 8, AN8, 80 on equals 1. Okay, and then interrupts, PIR1 bits 81F. So 81F is 0. So clear interrupt flag. 81E is on, 80IP is 1, 8IPEN is 0, disable priority levels. That's fine. And then PE1E is 1, G1E is 1. So it was the justification of the number that was messed up, I think. There we go. Okay, I got it. Now the PWM goes from like 1 to 1026. Alright, I fixed it. So now the real question is it giving a correct PWM output into the motor? And that, honestly, I have no idea. You know what this calls for? You guys know what this calls for? This calls for me to finally use my my long lost oscilloscope to actually see what's going on before I actually test this on a motor, because testing it on a motor is kind of scary. It is probably, yeah, it's only 8-bit. So it only takes the analog read is 10-bit, but it's mapping it down to 8-bit. So it's only taking the No. I think it's 10-bit. I gotta see this. Hold on. Datasheet time. Capture, compare PWM models, 139. Page 139. Here we go. CP. Yeah, 8-bit PWM, 10-bit 10-bit ADC. So it can be mapped. Yeah, it has to be mapped down. And I'll figure that out later. Let me get my oscilloscope thingies. It's been a while since I used them. Alright. Now, just to see that I'm not being a complete idiot at this, I'm gonna test the PWM signal with this thing. What if this is power? It's been so long since I used it. There's like dust everywhere. This poor thing. My neglected oscilloscope. It needs power to do so. USB-C 5 volts 2 amps. I have that thing. I have that connection. Here it is. USB-C 5 volts 2 amps. I've been used to this thing in such a long time. Oh, there's also dust here too! Dust everywhere! Okay. That's that. That's done. Let's wipe up some fingerprint marks on this thing. Connect my ADC clip. Okay. Getting some noise already. I'll turn my PWM to 0. And I believe I just need to measure it from these 2 pins. No, these 2 pins. Absolutely nothing's happening. Auto set. Absolutely nothing's happening. Let me just calibrate this using 5 volts. Okay, 5-volt division, 2.5-volt division. There's nothing on channel 2, so I can just turn that off. And then so I can measure the so like this difference is okay. So you can see the potentiometer working. I'm not saying that's false. Okay. Now I have to measure the output of the signal here, which is over here. And absolutely nothing is changing. So, in conclusion, there's no PWM. There's no PWM happening. It's just 0 volts. Okay, what's wrong? Oh, it is wrong. Okay, so I've got the ADC working because of the pin configurations. Now I gotta find out why the PWM is not working. Great. Yes, I have configured the ports. I literally copy pasted code from a professor. It's very configuration. So I've set the PR2 to 249, set the T2 con bits T2 CKPS 0x00, which is a prescaler. Set TMR2 onto 1, which is timer 2. So I've configured timer 2, set up CCP2 in PWM mode, which is going to be trisp.rb3. And these CCP2 con bits. I don't know if it's configured correctly because I changed the ports. Let me check if it's actually like, it's not detecting the wrong port, right? It's no longer on port C. 700. Why is there 1 volt here? I highly doubt that's the case. That's not the case. The potentiometer works. It's very responsive. Are you loading the number in the PWM buffer? Sure hope so. Yeah, I'm setting the AD-REST-H to CCPR2L, and then CCP2 con bits DC2B. That might be the wrong one. Let me see what these channels are. CCP R2L. This timer 3. Capture mode operation block diagram. Scared me. Thank you, Streamers Life Matter, for the follow. Eight bit should not be 200 and 255. I don't know why he assigned it like this then, because he assigned it to CCP R2L to AD-REST-H, and then he set CCP con bits DC28 to AD-REST-L, right shifted 6, and it to 0x03. Oh, thank you. It's not a project. It's my lab. So, it's... Hold on. What is it loading it to? CCP2 con bits DC2B. So you're setting. So in order to set the duty cycle, you have to set CCP R2L to something, and then the CCP converts DC2B to something else. This is programmed using C. Right, okay. So set up CCP2 in PWM mode, which is tris C bits are C1 to 0. I don't know if the second part is accurate. CCP2 con2 bits dot CCP2M. Let me see what that is. Right, that shouldn't make a change. DC2B. Okay, let me go ahead and see what that is. So I'm gonna print volatile int CCP1 volatile int CCP2. I'm gonna set CCP1 equal to CCPR2L. See what that is, and then CCP2 equals to CCP2 con bits dot DC2B. Okay, and I'm gonna print that out. So set cursor to like 1 0. Row 1, no. Row 1, column 0. And then print 1. Print int CCP1. Print 2. Print int CCP2. Okay, I just want to see what this is. Build failed. 7 errors generated. I'm just going to rename it to test 1 and test 2. I didn't like that name. So test 1. I'm going to do 80 rush. And test 2. Set it equal to the 80 res L right shifted 6 0 0 3. And then test 1. Build failed. Why? One error generated. Where's the error? Print. Not line 92. Oh! Forgot an entire set of parentheses. This in Python. Okay. So now I'm going to print out a couple things. Oh no. It's 0 0 1. Okay. So CCP1 is going to be 80 res H. So whatever's on the high bit. And then CCP1 should be whatever's on the low bit. Or like at least CCP con bits.dc2b. Theoretically. I don't know why they gave me assembly with 18 mega 328p in college. This is assembly with PIC, but like that sounds equally as painful. I had to do assembly earlier on the course, but like not now. trying to figure out why there's no voltage being outputted to my PWM here. So it seems like it is counting correctly. I think there should be like a C course, like for like just hardware C course before you get to assembly. But our school just didn't do that for some reason. Is this 4 bits or 8 bits? Like what is going on here? Because theoretically it's putting it in high and low. Low is CCP2. That's why it's changing so much. CCP2 is the 80 res L, right shifted 6. So it's taking the higher 6 bits, and then hold on. It's right shifting it by 6, and then only taking the top 2 bits. So basically, it's reducing the resolution from it's reducing the resolution of this thing from basically a 10-bit ADC to a 4-bit PWM. Okay, yeah, so it's 4 bits. This thing is 4-bit. Why is it not assigning it correctly? CCP con. Yeah, so it got the TRISB RB3 bits. TRISB equals 0x04, so I got the potentiometer input. That's right. What else am I missing? ADC is fine. It's assigning it to the PWM pin. The only thing I can think of is the CCP2 con bits.ccp2m is wrong. What the heck is that though? CCP2 con bits dot con. Special function register. I think that's a 1100, which means that CCP2M3 is set to on. 8-bit is 2 pairs of 4-bit, 1 lower part, 1 higher part. It's not even that. The lower part is 2 bits. The higher part is 2 bits. It's a 4-bit. Like, look. The way it's mapped right now is that the lower part goes from like, or am I looking at things wrong? The highest point is 3 and 3, so it's like 1 1 and then 1 1 on the lower one. Like this is the lower half. This is the higher half. It's a 4-bit PWM. All right. Okay. Hold on. I'm gonna end the stream soon, but like before I go, I'm gonna try to fix the PWM thing. I'm gonna go ahead and use this this thing here to make sure my circuit works. I use it for drones and stuff, but in this case, I'm gonna use it to test if my PWM stuff works. Just grab a test wire. Ugh. It's fine. So I think it's signal is the top one, plus is the middle, and the bottom one is minus, I believe. Let's test it out. So plus, minus. Okay, I was right. The top one is signal. Okay. So plus, minus, put in here. This one has a beefy PWM signal. It goes from 800 to 2200. And then we're just gonna plug it into like a random one just to see if it works. Okay, offset. Show me some PWM. Yeah. Show me some pulse width modulation. It's not doing it. It's not so high. The fact that it's like all the way. Let me see if I can increase the division. Control. Oh. 50% trigger. How do I increase this division here? T cursor. No. Measure? Oh, I just clicked on it. Okay. Okay, so this is what it looks like. This is the PIC 18F4321. So if I rotate this here, you can see it's going to shrink and then grow, basically. So this would be like about 50% PWM. It doesn't go all the way to the bottom, though. So from 800 all the way to 1200 is what it is. So theoretically, if I go ahead and plug it into here now, what it should be getting at is giving this signal a PWM pin. Alright, I'm ready for things to get hot. Wait a second. Hold on. Could it be that my circuit is wrong? Maybe. Okay, I gotta unplug stuff. Okay, so I'm gonna unplug this wire that's feeding into the PIC. So if the PIC is not the issue, then the issue is somewhere within the circuit we just built. Okay, it's only giving me like one signal, and not repetitive signal. Nothing's getting hot still. Oh, this would be the time thing, right? This is a very small PWM compared to like if this was just isolated. It reduces. Do I get rid of the resistor? Yeah, because like the PWM is getting low. I think the circuit's wrong. It doesn't like functioning correctly. Also, this servo consistency meter doesn't really have good consistency. The PWM is so small. Am I sure it's like dividing it correctly? It's signal 5-volt ground, right? It's so small. I wonder if I'm using this thing correctly. Circle. How to use this thing? Yes, give me a video. So it's signal 5 volts. I was using it correctly. It just wasn't giving me good PWM values. Okay. So I know that works. Now let me go ahead and try it out on the pin itself. Okay. And there's absolutely nothing. Maybe it's not grounded correctly? No, sometimes grounding is the issue. Now there's nothing. Okay, I'm gonna have to figure this out later. I think it may be a combination of the fact that I assigned the pins wrong and I also built the circuit wrong. But I don't have time for that now, so I'm gonna end the stream and then come back to this at a later time. All right? Okay. This little thing can rest now. It's done its job for today. Let's go raid someone. I need to do some other work now. Those are nice, easy MOSFETs, but something's wrong and I don't know what, so I'll figure it out later. Let's go raid Maker Deck. Okie doke. Well, thank you for watching my stream today. Hope you had a great time here. Hope you have a nice rest of your day, and I'll see you later. All right, guys? Bye for now. I'm out of here.